A mirror is an object that reflects light in such a way that, for incident light in some range of wavelengths, the reflected light preserves many or most of the detailed physical characteristics of the original light. This is different from other light-reflecting objects that do not preserve much of the original wave signal other than color and diffuse reflected light. The most familiar type of mirror is the plane mirror, which has a flat screen surface. Curved mirrors are also used to produce magnified or diminished images or focus light or simply distort the reflected image. Mirrors are commonly used for personal grooming or admiring oneself, decoration, and architecture. Mirrors are also used in scientific apparatus such as telescopes and lasers, cameras, and industrial machinery. Most mirrors are designed for visible light. However, mirrors designed for other wavelengths of electromagnetic radiation are also used. History. The first mirrors used by people were most likely pools of dark, still water, or water collected in a primitive vessel of some sort. The earliest manufactured mirrors were pieces of polished stone such as obsidian, a naturally occurring volcanic glass. Examples of obsidian mirrors found in Anatolia have been dated to around 6000 BC. Polished stone mirrors from Central and South America date from around 2000 BC onwards. Mirrors of polished copper were crafted in Mesopotamia from 4000 BC, and in ancient Egypt from around 3000 BC. In China, bronze mirrors were manufactured from around 2000 BC, some of the earliest bronze and copper examples being produced by the Qijia culture. Mirrors made of other metal mixtures such as copper and tin speculum metal may have also been produced in China and India. Mirrors of speculum metal or any precious metal were hard to produce and were only owned by the wealthy. Metal-coated glass mirrors are said to have been invented in Sidon in the 1st century AD, and glass mirrors backed with gold leaf are mentioned by the Roman author Pliny in his Natural History, written in about 77 AD. The Romans also developed a technique for creating crude mirrors by coating blown glass with molten lead. Parabolic mirrors were described and studied in classical antiquity by the mathematician Diocles in his work on burning mirrors. Ptolemy conducted a number of experiments with curved polished iron mirrors, and discussed plane, convex spherical, and concave spherical mirrors in his Optics. Parabolic mirrors were also described by the physicist Ibn Sal in the 10th century. And Ibn el-Haytham discussed concave and convex mirrors in both cylindrical and spherical geometries, carried out a number of experiments with mirrors, and solved the problem of finding the point on a convex mirror at which a ray coming from one point is reflected to another point. By the 11th century, clear glass mirrors were being produced in Moorish Spain. In China, people began making mirrors with the use of silver-mercury amalgams as early as 500 AD. Sometime during the early Renaissance, European manufacturers perfected a superior method of coating glass with a tin-mercury amalgam. The exact date and location of the discovery is unknown, but in the 16th century, Venice, a city famed for its glass-making expertise, became a center of mirror production using this new technique. Glass mirrors from this period were extremely expensive luxuries. The Saint-Gobain factory, founded by royal initiative in France, was an important manufacturer, and Bohemian and German glass, often rather cheaper, was also important. The invention of the silvered glass mirror is credited to German chemist Justus von Liebig in 1835. His process involved the deposition of a thin layer of metallic silver onto glass through the chemical reduction of silver nitrate. This silvering process was adapted for mass manufacturing and led to the greater availability of affordable mirrors. Nowadays, mirrors are often produced by the wet deposition of silver directly onto the glass substrate. Manufacturing. Mirrors are manufactured by applying a reflective coating to a suitable substrate. The most common substrate is glass, due to its transparency, ease of fabrication, rigidity, hardness, and ability to take a smooth finish. The reflective coating is typically applied to the back surface of the glass, so that the reflecting side of the coating is protected from corrosion and accidental damage by the glass on one side and the coating itself in optional paint for further protection on the other. In classical antiquity, mirrors were made of solid metal and were too expensive for widespread use by common people. They were also prone to corrosion. Due to the low reflectivity of polished metal, these mirrors also gave a darker image than modern ones, making them unsuitable for indoor use with the artificial lighting of the time. The method of making mirrors out of plate glass was invented by 16th-century Venetian glassmakers on the island of Murano, who covered the back of the glass with mercury, obtaining near-perfect and undistorted reflection. For over 100 years, Venetian mirrors installed in richly decorated frames served as luxury decorations for palaces throughout Europe. But the secret of the mercury process eventually arrived in London and Paris during the 17th century, due to industrial espionage. French workshops succeeded in large-scale industrialization of the process, eventually making mirrors affordable to the masses. Although mercury's toxicity remained a problem, in modern times, the mirror substrate is shaped, polished and cleaned, and is then coated. Glass mirrors are most often coated with silver or aluminium, implemented by a series of coatings: tin chloride, silver, chemical activator, copper, paint. The tin chloride is applied because silver will not bond with the glass. The activator causes the tin, silver to harden. Copper is added for long-term durability. The paint protects the coating on the back of the mirror from scratches and other accidental damage. In some applications, generally those that are cost-sensitive or that require great durability, mirrors are made from a single, bulk material such as polished metal. For technical applications such as laser mirrors, the reflective coating is typically applied by vacuum deposition on the front surface of the substrate. This eliminates refraction and double reflections and reduces absorption of light by the mirror. Technical mirrors may use a silver, aluminium, or gold coating, and achieve reflectivities of 90 to 95% when new. A protective transparent overcoat may be applied to prevent oxidation of the reflective layer. Applications requiring higher reflectivity or greater durability, where wide bandwidth is not essential, use dielectric coatings, which can achieve reflectivities as high as 99.999% over a narrow range of wavelengths. Types of glass mirrors. There are many types of glass mirrors, each representing a different manufacturing process and reflection type. An aluminium glass mirror is made of a float glass manufactured using vacuum coating, i.e., aluminium powder is evaporated onto the exposed surface of the glass in a vacuum chamber and then coated with 2 or more layers of waterproof, protective paint. A low aluminium glass mirror is manufactured by coating silver and 2 layers of protective paint on the back surface of glass. A low aluminium glass mirror is very clear, light transmissive, smooth, and reflects accurate natural colors. This type of glass is widely used for framing presentations and exhibitions in which a precise color representation of the artwork is truly essential, or when the background color of the frame is predominantly white. A safety glass mirror is made by adhering a special protective film to the back surface of a silver glass mirror, which prevents injuries in case the mirror is broken. This kind of mirror is used for furniture, doors, glass walls, commercial shelves, or public areas. A silkscreen printed glass mirror is produced using inorganic color ink that prints patterns through a special screen onto glass. Various colors, patterns, and glass shapes are available. Such a glass mirror is durable and more moisture-resistant than ordinary printed glass and can serve for over 20 years. This type of glass is widely used for decorative purposes. A silver glass mirror is an ordinary mirror, coated on its back surface with silver, which produces images by reflection. This kind of glass mirror is produced by coating a silver, copper film and 2 or more layers of waterproof paint on the back surface of float glass. which perfectly resists acid and moisture. A silver glass mirror provides clear and actual images, is quite durable, and is widely used for furniture, bathroom and other decorative purposes. Decorative glass mirrors are usually handcrafted. A variety of shades, shapes and glass thickness are often available. Effects. Shape of a mirror surface. A beam of light reflects off a mirror at an angle of reflection equal to its angle of incidence. That is, if the beam of light is shining on a mirror surface at a degree angle vertically, then it reflects from the point of incidence at a degree angle from vertically in the opposite direction. This law mathematically follows from the interference of a plane wave on a flat boundary. In a plane mirror, a parallel beam of light changes its direction as a whole, while still remaining parallel. The images formed by a plane mirror are virtual images, of the same size as the original object. In a concave mirror, parallel beams of light become a convergent beam, whose rays intersect in the focus of the mirror, also known as converging mirror. In a convex mirror, parallel beams become divergent, with the rays appearing to diverge from a common point of intersection, behind the mirror. Spherical, concave and convex mirrors do not focus parallel rays to a single point due to spherical aberration. However, the ideal of focusing to a point is a commonly used approximation. Parabolic reflectors resolve this, allowing incoming parallel rays to be focused to a small spot, almost an ideal point. Parabolic reflectors are not suitable for imaging nearby objects because the light rays are not parallel. Mirror image objects viewed in a mirror will appear laterally inverted, but not vertically inverted. However, a mirror does not usually swap left and right any more than it swaps top and bottom. A mirror typically reverses the forward-backward axis. To be precise, it reverses the object in the direction perpendicular to the mirror surface. Because left and right are defined relative to front, back and top, bottom, the flipping of front and back results in the perception of a left-right reversal in the image. Looking at an image of oneself with the front-back axis flipped results in the perception of an image with its left-right axis flipped. When reflected in the mirror, your right hand remains directly opposite your real right hand, but it is perceived as the left hand of your image. When a person looks into a mirror, the image is actually front-back reversed, which is an effect similar to the hollow mask illusion. Notice that a mirror image is fundamentally different from the object and cannot be reproduced by simply rotating the object. For things that may be considered as two-dimensional objects, front-back reversal cannot usually explain the observed reversal. In the same way that text on a piece of paper appears reversed if held up to a light and viewed from behind, text held facing a mirror will appear reversed, because the observer is behind the text. Another way to understand the reversals observed in images of objects that are effectively two-dimensional is that the inversion of left and right in a mirror is due to the way human beings turn their bodies. To turn from viewing the side of the object facing the mirror to view the reflection in the mirror requires the observer to look in the opposite direction. To look in another direction, human beings turn their heads about a vertical axis. This causes a left-right reversal in the image but not an up-down reversal. If a person instead turns by bending over and looking at the mirror image between his/her legs, up-down will appear reversed but not left-right.